Okay, here we're going to be working on the solubility curves worksheet for our new unit. So here you can see we got a graph, a chart, a solubility curve graph of a bunch of different chemicals and their curves. So number one, potassium nitrate at 70 degrees. Remember, we're supposed to find the mass of the solute. So 70 degrees is right here. So KNO3 looks like right there. And so we're going to say 130 grams. Sodium chloride at 100 degrees. So right here, sodium chloride right there, it looks like 40 grams. NH4Cl at 90 degrees. 90 degrees right here until we hit NH4Cl. Looks like right there. So 70 grams. Which of the above three substances is most soluble in water at 15 degrees? So 15 degrees is going to be right here. So I'm going to make this sort of imaginary line so I can compare all these things. And KNO3 hits it right there. Oh, sorry, that's KCO3. KNO3, apologies. KNO3 hits it right here. NaCl hits it right here. And NH4Cl hits it right there. So which one is the most soluble? It's the one that's at the top. And that looks like it is NaCl. All right, moving on. A solution contains actually, hold on, let me just quickly erase what I've done here. Okay, and back we go. A solution that contains 70 grams of sodium nitrate at 30 degrees. So 30 degrees, right there. 70 grams at 30 degrees is right here. And we're interested in NaNO3. So this is how much it can dissolve. Looks like about 95. And this is how much it does dissolve, about 70. So this is definitely unsaturated. And it looks like you could go about 25 grams more, right? 95 minus 70. 50 grams of NH4Cl at 50 degrees. So 50 degrees, 50 grams. So I'm just going to make a little dot right here. And that looks like it's right on the line. This would be saturated. 40 grams of potassium chlorate at 50 degrees. So let's go 50 degrees, 40 grams. Put a little dot right there. And we're interested in KCl3. It looks like we're above it, so we are definitely supersaturated. And 35 of potassium iodide at 0 degrees. So 0 degrees, 35 grams is going to be right here. And Ki, now you could actually dissolve this much, 130, and you've only dissolved 35, so the difference there is 95 grams. So this is unsaturated with a difference of, you could add about 95 more grams, right? 130 minus 35. So what's the solubility of KCl at 5 degrees? Okay, so again, let me just erase all the stuff I've done up to here. Start from scratch. We'll go green. What is the solubility of KCl at 5 degrees? KCl is right there at 5 degrees. Looks like it's right here. I'll ballpark that at 28. 28 grams per 100 milliliters. What's the solubility of 25 degrees? Same line, 25 degrees. That's going to be approximately right here. It looks like around, I don't know, 35. It's a little less. It's like 34. 34 grams per 100 milliliters. Cesium sulfate at 10 degrees. Cesium sulfate is this bottom one at 10 degrees. Looks like right there. I'm going to call that 14. Why am I doing like over 100 milliliters? Remember that this is per 100 grams of water, which is the same thing as 100 milliliters. So what is the solubility of cesium sulfate at 50 degrees? So again, cesium sulfate, 50 degrees, looks like right there. We're going to ballpark that at 5. At 90 degrees, you dissolve 10 grams of potassium chloride and 100 grams. It's a saturated. Okay, so 90 degrees, 10 grams. 90 degrees, 10 grams. That's a dot right there. And we're looking at KCl, which is, where's KCl? That's right here. So that is definitely unsaturated, right? Because you're well below the curve. So that's unsaturated. And so hold on one second. We're gonna pause this thing. Oops, sorry about that. So I'm sorry, I'm not gonna stop and re-record. Notice it says it's 100 grams. It's not 10 grams. I misread that. So let's just quickly jump again. That's not that one. It is 100 grams. So again, my apologies. I'm not gonna re-record. So we're still interested in this KCl curve right here, or in the double checking it. NaNO3. That is this curve right here. So you're unsaturated right now, right? So as this thing cools, we're going to move this way. We're going to get closer and closer to this line, the saturation line. As soon as we pass into this area up here, like over here, then that we're super saturated, and that's when precipitates come out. Because the precipitates form because the solution is super saturated and it can't absorb anymore, so that it comes out as a solid. So we're interested in this spot right here is where the solid will form, and that looks to be about around 35 degrees. So 35 degrees Celsius. Again, I'm not going to re-record that. I might trim it though. What compound is the most soluble at 20 degrees Celsius? Actually, okay, which compound is the most soluble at 20 degrees? So 20 degrees Celsius, we could jump over here. The most soluble is the one at the very, very top. That's going to be this one right there, Ki, potassium iodide, which is the least soluble at 40 degrees. So 40 degrees, which one has the least? It's this one right here. It looks like cesium sulfate. So Ce2. So Ce2, and then 3 sulfates. Which substance is the least soluble at 10 degrees Celsius? That looks like this one right here. That's going to be KClO3. A mass of 80 grams of potassium nitrate is dissolved at 50 degrees Celsius. The solution is heated to 70. How many more grams can you add to make it saturated? Okay, so 80 at 50 degrees. So let me just quickly erase my other stuff here. So 80 grams at 50 degrees is going to be a little dot right there. And it's KNO3 and it's heated to 70. So KNO3 and it's heated to 70. So it has jumped here. And how many more can we add? Well, we're going to go up until we hit the saturation line. And it looks like we can get up to 130. If we already had 80 and when you can get up to 130, that means we can add 50 more. Right, so we can add 50 grams to hit the saturated line, so our saturation point. Okay. So here we're going to have to do some graphing, and I'm going to basically just cut the video here, and I'll come back when I have finished plotting these points because I don't want to just sit there and record myself plotting points. Okay, I have plotted all the points and connected them with a smooth line using red for copper sulfate, green for sodium chloride, and I'm going to point out real quickly that I started my graph basically at 30 just because the lowest value was 35.7 or 23. So I guess technically right there would be 20, and this is up there is 30. So you don't have to start your graphs at 0, but I wanted to make sure I was able to fit this data point on the graph. Anyways, that's why it looks the way it looks. So at 65 degrees Celsius, you have 35 grams of sodium chloride dissolved in 100 milliliters of water. Okay, so let's. I'm going to mark these 2 points. So at 65 degrees Celsius, which is right there, 35 grams of sodium chloride. I'm going to actually do this in green because that's my color for that. 35 grams. And that looks to be right on the line there, right? So right there. And it says we got 58 grams of copper sulfate. So 65, sorry, 58. 58 looks to be right around here. So the green one, this is right here, is definitely saturated. It's right on the line. This one right here is definitely unsaturated because we have some room to go still to hit the line. So if I'm at 58 right there, and it looks like I can go to a right around 64, I don't know, so 63, 64, let's call it 63. So if I'm at 58 and I can get to 63, that means I can add 5 more. So let me just, I guess I'm jumping questions here. How much more solute could you add to the unsaturated solute? I just figured this out. So 63 minus 58 is equal to 5 grams. I already said that the copper sulfate was the unsaturated one, right? Because it's the one that's below. Okay, and that is it.